So welcome to G.L.C school. Today we're looking at organic chemistry. So in last discussion we looked at hydrocarbons of alkenes. Today we'll look at hydrocarbons of alkenes. So under alkenes are also hydrocarbons. So they are called hydrocarbons because they are made up of these. They are made up of carbons and hydrogen atoms only. So they are also called hydrocarbons. Now alkenes, we say they are unsaturated. They are unsaturated hydrocarbons with double bonds between carbon atom. So these are unsaturated hydrocarbons because they contain double bonds between atoms. Now from here, we need to understand that because of double bond, they are reactive. They are reactive because they contain the double bonds. Alkenes. So alkenes, their names so the names of members ends with ENE. This one. So the names, they end with that. Then the last information we can give, the brief information we can give is that since the names end with this part, we need to understand the general formula. So the general formula is CnH2n. So this is the general formula which can help us to identify if this is an alkene or an alkane. Alright, so this information can help us to understand alkenes. Now remember in the previous video we said, in the introduction of chemistry, we said they have the prefix of meth. There is excuse me, F, there is prop, there is but, there is pent, there is eggs, hept, oct, non, and dec. So these are the prefix for all the organic families. So organic families now, they have the members. So these are the members. This is a family. So this family, it contains these members. So to end the name, we'll say, since these are alkenes, we'll put ENE. Then I'll explain about this one, don't worry. Then ENE, this is prop, so ENE, just like this. So these are the names of the members under alkenes. So heptane, octane, then this one, and so these are the 10 members of this family. Now, the first member, we don't consider it in the sense that it has no capacity to show us where a double bond is located. So this one is omitted. We'll start with this one. We start from here up to the last one. So these are the members which are going to look at their physical properties, the chemical properties, of course, and how they react in the chemical property. So let's move a bit. Now, from here, we'll look at the member, then chemical formula. Apart from this, we'll look at structural formula. Then, of course, you can look at condensed formula. A condensed formula. So member, we'll start with number 2, which is ethane. So since ethane is on number 2, that is the name, ethane. Now the chemical formula, for us to know the chemical formula, we'll say C2, the general formula, CnH2n, CnH2n. Then from here, since this one is on number 2, where there is N, we'll put 2. So it will be C2H2, then 2. So if you calculate, they are going to get something like this. So this is the molecular, the chemical formula for ethane. So we have C2H4. Structural formula. The structural formula will be now C double bond, C because of 2 carbons. Then we introduce our 4 hydrogen. This is a structural formula. Then the condensed formula will be the same because we are just on second carbon. So the condensed formula now, you have seen this C, this is my C. Then this C contains 2 hydrogen, so I'll put 2 hydrogen. Then this C, I'll put it here. It also contains 2 hydrogen, so I'll put 2 hydrogen. That's my condensed formula. Let's make another one, the third one, propane. Others they pronounce as propene. Others propane. So the same thing, we have CnH2n. Where there is N, we put now 3. So we're getting C3H, 3 times 2, you're getting 6. So I have 3 carbons, then I'll put my double bond here. If I want, I can put it here. So the first one, because it has only a single bond, it will have 3 hydrogens. So this one will have 1, this one will have 1. So 1, 2, 3, 4, 5. Then this one will have a privilege to have 2. So 1, 2, 3, 4, 5, 6. This is my structural formula of propene or propane. Then in the structural formula will give me the condensed formula. There is no way the structural formula and the condensed formula differ. It means that you have made a mistake. So we'll just get this carbon. So carbon has how many hydrogens? It has 3. So you put 3 here. The second carbon, it has how many hydrogen? It has 1. So just put like that one. Then the third one, it has 2. So it will be like that. So this is how I write the chemical the chemical formula, the structural formula, and the condensed formula under the family of alkenes. So now you can go on and try all the remaining from propene. So you start from butene up to the last one, so that you practice the same things. So having looked at how to write the condensed formula, the structural formula, and the chemical formula, we can now look at isomerism. Isomerism. So isomerism of alkenes, we're talking about a chemical compound which have same molecular formula but different structural formula. That kind of a compound is referred to as an isomer. It is different from an isotope or allotrope. So to learn that an isomer is an organic compound with same chemical formula but different structural formula. That type is called an isomer. So example, so e.g. we'll say, write the isomers of hexane. Hexane is the sixth member of this family. So for us to write the isomer, we need to understand that number one, we'll look at positioned isomer. Then number two, we'll look at branched isomer. So alkenes forms two types of isomers. The first one you have positioned isomer, then the second one you have the branched isomer. So on the positioned isomer, so we'll draw first the structural formula of this one, of hexane. Of course, you know that hexane will give us C6H12. So the original structure is like this. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so this one will have 3. This one will also have 3. So if there is single bond here, the first one should have 3 hydrogens. The last one should also have 3 hydrogens when there is a single bond here. Then here where there is a double bond, you just put 1 hydrogen. Then these will go with 2 hydrogens, like this. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is my structure of hexane. Now, if I want to write the positioned isomer of this one, I'll just shift the position of the double bond and put it anywhere. In that case, I've written my positioned isomer. So under positioned isomer, what you are saying is that in this type of an isomer, you just change the location of this double bond to anywhere. Once you do that, it means that you have done your positioned isomer. So this one, I'll write like this: 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So the first one is here. So I'll put it somewhere here. I'll put it here. So in that case, I have written my positioned isomer. So I have double bond here, I'll put 1. I have double bond, I'll put 1. Then here I'll put 3. So this is my isomer. This is my positioned isomer. As long as I've shifted my double bond, whatever will come, it is an isomer. So this one is very simple. Now, after you have written an isomer, you need also now to write the name, which is correct according to what you have positioned. This is where now the part comes in to understand this type of an isomer. So according to UPAC, if you UPAC name, so our UPAC name, let me write this here. Our UPAC name, International Unit of Pure and Applied Chemistry, that's what it means. According to our UPAC name, what I'm going to do now is that I need to count the number of carbons starting from where the carbon which is near to the double bond. So here we have 1, 2, 3, 4, 5. Now this one, 1, 2, I have found my double bond. So this means that this one will be my carbon 1, my carbon 2, my carbon 3, 4, 5, then 6. So in counting the number of carbons, ensures that you start from the carbon which is closer or near to the double bond. Hence, this one will be my 1. If this one was like in this case, 1 should start from here because this one is near to this one, to the double bond, than this one. Therefore, my name, the parent name will be maintained as hexane because the carbons in a straight line, they are 6. So they are equivalent to this prefix hexane. So my UPAC name now will be X. Now, here I'll put a dash, an hyphen. So this hyphen 1, 2, I'll put 2. Then I'll finish the name. So this number 2, it is representing the position of double bond. So it is saying the double bond is on carbon number 2. The double bond is on carbon number 2. So this is the UPAC name of this structure. So this is how we write the positioned isomer. So the first thing, you change the position of the double bond. The second thing, you count the carbons starting from the carbon which is near to the double bond. So this is how we do the isomer, which is a positioned one. Let's talk about the branched one. If there are any questions, please feel free to ask after you watch this video. The branched one, you normally we just look at we just have a branch of methyl group. So this is a methyl group. So methyl group is like this: C H H H. This is our methyl group. So this becomes a branch and it will change the name of the parent and we'll see what will happen. So if I want to write this one under the branched one, meaning that the parent name of hexane will move one step backward. It will go to pentane under branched one. When you use a branched isomer with this group methyl, the parent name changes from the original parent name to the name which is behind the original one. So we are saying that I'll say 1, 2, 3, 4, 5. Then I'll attach this group. So I'll use this part. I've attached it. Then my double bond is here. In the first one, I'll maintain it here. I'll maintain it here. On the second one, I'll maintain it there. Then I'll write my, so it is between this one, so it will have only 1, then 2, then 3, then 4. So I've used how many? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10, 11, and 12. So I've balanced this one and this one. So the carbons, we have 1, 2, 3, 4, 5. This one is 6. But this is the structure. This is the structure. But in terms of naming the structure, this is where the problem comes. The structure is correct, but now let's see how we name this one. The first thing, identify the name of the group, which is methyl group. Perfect. Number 2, identify the parent name. So the parent name, we get the parent name from the carbons which are in the straight line. We get the name of the parent which are in the straight line. So we have 1, 2, 3, 4, 5. So we know that we have pentane. Pentane is the parent name. Then the group is methyl group. All right. So having that now, let us write this name in a UPAC way. So the UPAC name now. All right. So the UPAC name will be like this. Let me have a good space here. So we know that now we have pentane and methyl group. All right. So the UPAC name will be like this. So the group which we have is methyl. Methyl group is touched on which carbon? Methyl group is touched on carbon number what? Remember I said when counting the number of carbons, you need to focus on the double bond. So the carbon which is nearer to the double bond, that carbon is positioned as the carbon number 1. So this one is closer to this one than this one. So because this one is nearer to this one, then you'll say this one will become 1, 2, 3, up to number 5. This is 4. So this branch is attached to carbon number 2. Therefore, we'll say 2 hyphen methyl. 2 methyl. 2 is representing carbon number 2, where this branch is touched. Then, what else? The name of the parent, we have pentane. So pentane, hyphen. Then, I'll put a number here, which will represent where the double bond is located. So in this case, 1, 2. Double bond is on carbon number 2. So I'll put 2 like this. So this is the UPAC name of this structure. This is the UPAC name of this structure. If I change this one, maybe put it here. Now I'll use the same one to explain everything. If I change this one, so 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So we'll start counting now the carbons from here, because this one is nearer to this one than this one. So in this case, it will be 1, 2, 3, 4, 5. Okay, so the methyl group now is touching carbon number 4. So here I'll put 4. There I'll put 4. So 4 methyl. 4 is showing the location where the branch is touching. Then these 2 will be maintained like this, because this 2 is showing the carbon which is attaching to double bond. So this is how I write the UPAC name. If I decide to shift this branch and maybe put it somewhere here, if the branch comes here, it means that I will move this one. The name will change, because now this branch is touching on carbon number 3. So here I'll put 3. If I decide to move this one and put it here, here I'll change, I'll put 1 because this double bond is touching to carbon number 1. So this is alright, a branched isomer and a positioned isomer. Alright, so if there are any other questions, you can ask in the comment section below. Then, apart from that, someone may ask, but do we always use the same branch? Normally, grade 12 level, we focus on methyl. We don't reach propyl or butyl or ethyl. Normally, we focus on ethyl. All right, so that's about isomerism of alkenes. Now let's look at the chemical properties. Okay, the chemical properties. Okay, so in the next video, I'll discuss the chemical properties so that I can make another short video, because if I introduce chemical properties, it means that the video will be long. So thank you for watching. If there are any questions, please you can contact me on this number 0971834379. You WhatsApp me. We add you in our group for online tuitions so that we prepare you for the exams.